Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Pivot is a Java-based open-source platform designed for building rich internet applications. Unlike traditional web applications, Pivot allows developers to create desktop-like experiences with rich user interfaces. It supports declarative UI definition using BXML, similar to FXML in JavaFX, and integrates seamlessly with Java for logic and data binding. Apache Pivot stands out for its declarative UI approach using BXML, which separates design from logic. It provides a rich set of UI components and strong data binding capabilities. Being Java-based, it ensures cross-platform compatibility and is ideal for modernizing legacy Java applications that need a richer UI. Apache Pivot's architecture is built around a component-based UI model, where each UI element is a component. It uses a scene graph for rendering, which allows for efficient updates and transformations. The UI is defined using BXML, while behavior is implemented using JavaBeans, making the architecture both flexible and modular. BXML, or Bean XML, is Pivot's way of defining UIs declaratively. It's similar to FXML in JavaFX and allows developers to define UI structure in XML format. This approach promotes separation of concerns, making it easier to maintain and update the UI without touching the Java code. Data binding in Apache Pivot allows automatic synchronization between the UI and the underlying data model. It supports both simple and complex bindings, reducing the need for boilerplate code. This feature is tightly integrated with JavaBeans and ensures that UI updates are event-driven and efficient. Apache Pivot's event handling system follows an event-driven programming model, similar to other Java GUI frameworks. It supports custom events, listeners, and handlers, providing a flexible and intuitive API. This system integrates well with Java's native event model, making it familiar to experienced Java developers. Pivot provides a robust set of graphics and drawing APIs for rendering 2D graphics. It supports custom drawing through a canvas-based model and integrates with Java 2D for advanced graphics operations. This makes it suitable for applications requiring custom visuals or animations. Apache Pivot supports skinning and themes, allowing developers to customize the look and feel of their applications. It offers a CSS-like styling system and supports dynamic skin switching. This extensible system makes it easy to create visually appealing and branded applications. Pivot includes built-in support for web services, with an HTTP client that handles REST and JSON out of the box. This makes it easy to integrate with web APIs and handle asynchronous requests. It also supports various authentication mechanisms, making it suitable for enterprise applications. When compared to JavaFX, Apache Pivot shares a similar declarative UI approach with BXML. However, JavaFX is more actively developed and supports mobile and embedded platforms. Pivot, on the other hand, excels in 2D graphics and is better suited for modernizing legacy Java applications. Compared to Swing, Apache Pivot is a more modern framework with a declarative UI approach. It offers better data binding, a richer component library, and is more suitable for building rich internet applications. While Swing is still widely used, Pivot provides a more contemporary development experience. A real-world use case for Apache Pivot is an enterprise dashboard application. Such an app would benefit from Pivot's rich UI components, real-time data binding, and integration with REST APIs. Custom skins allow for branding, and the cross-platform nature ensures broad deployment options. Apache Pivot's strengths include a rich set of UI components, strong data binding capabilities, and a declarative UI approach with BXML. It's lightweight, modular, and integrates seamlessly with the Java ecosystem, making it a solid choice for specific use cases. However, Apache Pivot also has its drawbacks. It has a limited community and is no longer actively developed. It lacks modern features like native mobile support and has a steeper learning curve compared to newer frameworks. Additionally, there are fewer third-party libraries available. To get started with Apache Pivot, begin by mastering Java and basic GUI programming. Then, learn BXML for UI design, explore data binding and event handling, and build sample applications. Finally, compare Pivot with modern frameworks to understand where it fits in today's landscape. Setting up Apache Pivot is straightforward. Since it's no longer actively developed, you'll need to download it from the Apache archives. Add the necessary JARs to your class path, configure your IDE for BXML, and set up build tools like Maven. Running sample applications is a great way to get started. Creating your first Apache Pivot application involves defining the UI with BXML, creating a Java class for logic, binding data and events, and then compiling and running the app. Testing UI interactions ensures everything works as expected. Once you're comfortable with the basics, explore advanced UI components in Apache Pivot. This includes creating custom components, skinning them, handling events in depth, and using graphics and animations. Performance optimization is also key for complex applications. Data binding in Apache Pivot goes beyond simple property synchronization. It supports complex bindings, binding expressions, and event-driven updates. Proper validation and error handling are crucial, and performance considerations should be taken into account for large datasets. Apache Pivot's event system is built around listeners and handlers. It supports custom event creation and follows a clear event propagation model. Asynchronous event handling is also possible, and the system integrates well with Java's native event model. Graphics and animation in Apache Pivot are handled through a canvas-based drawing model and integration with Java 2D. The framework supports animation and allows for custom visual effects. Keeping performance in mind is essential when working with complex graphics. Skinning in Apache Pivot allows for extensive customization. You can create custom skins using a CSS-like syntax, switch skins dynamically, and manage themes effectively. Performance should be considered when applying complex skins to large applications. Apache Pivot's built-in HTTP client makes it easy to integrate with web services. It supports REST and JSON, various authentication mechanisms, and asynchronous requests. Proper error handling ensures robust integration with external APIs. Performance optimization in Apache Pivot involves efficient data binding, UI rendering optimizations, and careful memory management. Following best practices for event handling and using profiling tools can help identify and resolve bottlenecks. Security is crucial in any application. In Apache Pivot, ensure proper input validation, implement authentication and authorization, make secure web service calls, and consider data encryption. Following security best practices helps protect your application and its users. Testing Apache Pivot applications involves unit testing UI components, integration testing with web services, and automated UI testing. Mocking and stubbing can help isolate components, and continuous integration ensures consistent quality. Apache Pivot applications can be deployed as standalone JARs, launched via WebStart, or packaged with native installers. Cross-platform considerations and performance tuning are important for a smooth deployment experience. Debugging Apache Pivot applications can be made easier with IDE debuggers, logging and tracing, UI inspection tools, and event flow analysis. Performance profiling helps identify bottlenecks and optimize the application. While Apache Pivot is no longer actively developed, resources are still available in the Apache archives. Community forums, sample projects, and third-party libraries can provide additional support. Keep in mind that legacy support considerations may apply. Apache Pivot is no longer under active development, with maintenance now community-driven. For new projects, migration to modern frameworks like JavaFX or Vaadin is recommended. However, it remains significant for legacy application support and historical context. Migrating from Apache Pivot to a modern framework involves assessing current applications, choosing a target framework like JavaFX, planning migration steps, refactoring UI and logic, and thoroughly testing the new application before deployment. A case study in legacy app modernization might involve identifying a legacy Pivot application, analyzing its UI and data flow, planning a migration to JavaFX, refactoring and testing the new version, and deploying the updated application with improved performance and features. To wrap up, best practices for Apache Pivot include using BXML for UI design, leveraging data binding, optimizing performance, following security guidelines, and planning for long-term maintainability. These practices ensure robust and efficient applications. Common pitfalls in Apache Pivot development include ignoring performance, poor data binding design, inadequate testing, security oversights, and neglecting migration planning. Avoiding these pitfalls ensures a smoother development and deployment process. Several tools and extensions can enhance Apache Pivot development. IDE plugins for BXML, build tools like Maven, profiling and debugging tools, third-party libraries, and UI design tools all contribute to a more efficient workflow. In summary, Apache Pivot is a powerful tool for building rich Java UIs with declarative UI design and strong data binding. While it's ideal for legacy support, migration to modern frameworks is recommended for new projects. Community resources and tools are still available to aid development. Thanks for watching this deep dive into Apache Pivot. If you found this video helpful, hit that like button and subscribe for more tutorials. Drop a comment with your questions or thoughts, and share this video with fellow developers. Stay tuned for our next video. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.